Okay. So for the first 40-45 minutes of the lecture, I would be focusing only on the concept of factor analysis. So would request all of you to please you can put your laptops on sleep mode for some time so that you basically understand the concept. People sitting at the back can also join us in the front. It will be better for you all to understand, and there'll be less possibility of sleep as well, because the class is after the break, so you all can come up in the front. Otherwise, you can stay where you are. Right. So now the topic that I will be discussing today is factor analysis. Now, since this workshop is basically focusing on advanced multivariate techniques, so definitely factor analysis is one such advanced multivariate concept. Now, what is basically the difference between linear regression and factor analysis? Like, I'm continuing with the just previous lecture that you had about multiple linear regression. So I'm trying to link this concept of factor analysis with MLR, and would also like to sort of differentiate that what is different in case of factor analysis, and why it is important to study factor analysis, what is new in this technique, and for that matter, why do we even want to study this concept? So answering the first question, that is why factor analysis is different from MLR. So basically, when we talk about multivariate data analysis, multivariate, of course, everybody knows when we deal with more than two variables at the same time. When we talk about handling multivariate data, there are two types of, so broadly we can classify the concept of multivariate data analysis into two parts. One is called dependence technique, and the other is called interdependence. Now, what's the basic difference between dependence and interdependence? When we talk about dependence, means that we have one dependent variable and we will have, say, one independent variable, a set of independent variables. Suppose if we have one dependent and one independent variable, that's simply called simple linear regression, where you have one y and one x, and when we try to model the relationship and build a model and then solve, that's simple linear, which we've already discussed in detail, everybody. Now, since most of the participants here are from non-statistics background, which I have been informed, so I would not try to go much into the details of statistics, but still, since it's a statistics department, so definitely we'll be focusing on that as well. But just in case anybody has any question, please feel free to raise your hands and you can ask right away in the middle of the session, okay? So I was talking about the difference between dependence and interdependence technique. Now, when we talk about dependence, we have one y and one x or several x. So y and x, what does this mean? Dependent and independent way. However, when we talk about interdependence technique, this means that you have some variables, which is definitely a multivariate data, but you don't know, or rather, there is no information that is being given to you about the relationship between the variables. That is, you don't know which a variable could be a y, which could be an x, or maybe several variables x. So there's no sort of dependence between, or there might be some dependence, but you are unaware about that. So there is no dependent and independent variable. You just have a set of variables. That is called, so when you have a set of variable and you have to deal with that, that kind of multivariate technique is called interdependence. However, when you have an independent or maybe many independent and one dependent variable, or maybe several dependent variable, that is called dependence technique. So factor analysis, for that matter, is an interdependence technique. Number one, where we do not have any information about y, or rather dependent or independent variable. You just have a set of variables. Now, since you have set of variables, it's a multivariate technique as well. Now, why? So that's basically the difference. Now, why do we need to do factor analysis, or what is the use of that? It is a dimension reduction technique. Now, what is dimension reduction? Suppose if we have like a set of variables. Now, I'll try to explain this to you with the help of an example. Now, there are many abstract concepts. Like, for example, suppose if we need to measure anxiety level, okay, or depression. Now, you don't have one single measurement method by which you can sort of measure. Suppose if we need to measure the weight, person can just stand on a weighing scale and you understand what is the weight of the individual, right? For depression, we don't have one single way by which we can find out what is the level of depression. So what do we do? There might be some students from psychology as well, or you might know that there are different scales which are constructed, they are validated, and with the help of those scales, we try to assess that what is the depression level or what is the anxiety level. All right, how do we do that? Now, there are set of questions, not one single question, there are set of questions. On the basis of those questions, you try to, so you give that question to an individual, the individual tries to answer it, you gather the data, and on the basis of the responses, after analyzing, you maybe classify the individual into like whether, mild, moderate, severe, or what is the status of their depression level. For these kind of abstract concepts, what are we doing? We are using a scale that has multiple questions, that has many questions. Sometimes there are well-developed scales that have been tested across, they have been validated, people have been using it over time. But in many cases, you need to develop your own scale. So depression, anxiety are very standard concepts, and there are a lot of scales that have been developed. But for many concepts, you need to develop your own scale, or maybe you need to develop a scale that is adaptive to your own conditions, your own situations. So in that case, or for that scenario, you have to develop your own scale. When you do that, you take up several questions. When you take up several questions, it might be a possibility that you are having repeated questions in your questionnaire, or maybe there are a couple of questions that are pointing towards the same thing and they are unnecessarily in the questionnaire, things like that. To deal with such kind of situation, you need to develop a process that helps you to identify, to reduce the dimension of your data. Dimension means there are a lot of variables. Now you need to identify that can there be any possibility or any method by which we can try to reduce the dimension. Now, how are you going to do that? Reduce the dimension in putting it in very simpler way, I can say remove some variables so that your questionnaire or your scale becomes more crisp, right? How are you going to do that? For that, number one, you need, do I need to address the chats also? Okay. So for that, you need to see, first of all, which are those variables that need to be, or which are those questions, in other words, which need to be put in your questionnaire, and which are those questions or variables that can be removed from the questionnaire or that are not playing a very significant role. So fact analysis is one such technique that helps you to reduce your dimension by identifying those variables which are actually playing some role in describing a particular concept or a phenomenon. And how does this work? It works by dealing with the amount of variation that is being explained by particular variable. Now, why do we talk about variation? Now, I think like all of you who are sitting here, at least have some idea about the statistics. And if you have some idea, you already know what is the importance of variation or variability when we talk about statistics. Now, having said that, again, coming to the point that I already said, that when we talk about factor analysis, it deals or addresses those variables, or rather identifies those variables that have higher variation or that are able to explain higher variation. What actually this means? Suppose if I make a questionnaire, I'll again use the same example that I was talking about, depression. Suppose if I have made a questionnaire that has a lot of questions on depression and it is trying to measure the depression scale. Suppose if I circulate the questionnaire amongst all of you and I get some response and I try to record those response. When I enter it into a system and like when I or my student or anybody tries to analyze it, then we see that there is like almost all the responses are the same, which means the depression level or the mental level of everybody sitting here is exactly or almost the same. Is it practically possible? No. Why? Because there might be some difference in everybody's mental status. Some might be very happy at this moment. Some might be struggling with some problem. It's not necessary that everybody would be having exactly same mental level, right? If your data, or rather the scale that you have given, the questionnaire that you have given, if it is showing that the responses are almost identical, it means identical to hai nahi. So there is definitely some problem in the scale that you've constructed, which means the questionnaire that you are or you have developed, there might be some problem in that questionnaire. It is not able to properly address or properly cater to your question or your study objectives. Which means what? Larger the variation in the responses, more precise or better is your tool. इसका मतलब ये भी नहीं है that there should be a wide variation. I'm also not indicating that, but at least it should try address the variation. It should try to point out the variation. This is exactly what is the concept of factor analysis. It tries to identify those variables or rather those questions in a scale that is able to address this issue of variation, that explains maximum variation. Throughout this concept of factor analysis, we will be talking about variation under study. You will listen to this term many times. This is what it actually means. Bigger the amount of variation means the more precise is your measuring instrument or your tool or your questionnaire, whatever you call it. So that's what factor analysis does. It tries to reduce the dimension of your data by identifying those variables which are able to explain maximum variation and those variables which are not exhibiting a higher amount of variation, which means they might be good in some sense, but definitely they are not able to address to the study question that you have in your mind. मतलब वो किसी और concept के लिए they might be useful, but definitely not useful to study the level of depression. So this is how it tries to reduce the dimension by studying the variances. Is this basic concept clear to everybody? Right? So what is factor analysis? Is a dimension reduction technique, is an interdependence technique. You don't have a bifurcation of Y and X, rather dependent and independent. You have a set of variables, you try to reduce the dimension. Why do you want to reduce the dimension? Because it's a huge data and you might feel that there are some variables or questions that are redundant that might be addressing a similar problem. You want to identify those that might play a major role or a pivotal role in handling particular situation or like a depression or anxiety, whatever, and you try to identify those variables. After identifying, you can use only those or maybe set of those variables and remove the others. So your dimension of your entire multivariate data is reduced. right? Basic concept is clear. So this is what's written here is just what I've already explained. So I'm not reading this out. I might share this slides with all of you so you can read it. There's nothing new that's written here. It's an interdependence technique. Yeah. One more very important concept here is the difference between exploratory factor analysis and confirmatory factor analysis. There are two types of factor analysis. What is EFA? EFA is exploratory factor analysis, which I would be discussing here in the class right now. What is EFA? It uses your data, and with the help of your data, it tries to build the hypothesis. Again, I am repeating, it uses your data, that is the data that I have, without any bifurcation of Y and X. Using the data, it tries to build, you are trying to develop some hypothesis. You are trying to build some hypothesis. What do I mean when I say build some hypothesis? You are trying to develop certain relationships. There might be some relations, some type of relationships which might be evident or clear after EFA. So it uses the data and then develops or builds the model or hypothesis. On the other hand, CFA tests your hypothesis, confirms the model that has already been developed by exploratory factor analysis. Putting it another way, I can say that whenever we do any type of analysis, we perform certain basic descriptive statistics, and after that we go into testing. That's the basic thing. All of you, be it any stream, whenever we go for any statistical analysis, what do? The first table generally contains of the mean, standard deviations, frequency distributions, basic statistics, and the next one is chi-square, T, F, any other type of test that kind of validates what you are intending to test. This is exactly what is the difference between EFA and CFA. When we talk about EFA, it's just a basic description, a descriptive exploratory type of work that we are doing, wherein we are trying to build certain hypotheses with the help of data, like what is it indicating? And then we are validating it or testing it, confirming it using confirmatory factor analysis. EFA can be easily done using SPSS software, which we will be discussing today in detail. But when we talk about confirmatory factor analysis, it is done using an add-on module. You see, SPSS mein, there is this add-on module that could be purchased and could be added. It is called AMOS. So using that structured equation modeling, we perform confirmatory factor analysis, that is CFA. It keeps on testing the hypothesis that you have developed or built on the basis of exploratory factor analysis. So is the difference between the two also clear? So CFA is one step ahead of EFA. So right now we will be only focusing on exploratory factor analysis. So EFA is data driven, as I already said. On the basis of data, we try to build or develop the hypothesis. While when we talk about confirmatory factor analysis, we test the hypothesis that has already been built using EFA. So it is theory driven. Theory driven means there is some theory. वो hypothesis जो बनी है, उसके पीछे there is definitely some concept, some theory, and then we try to test. So when I was talking about factor analysis, I said that we try to reduce the dimension of the data. It's a dimension reduction technique. How do we do that? There are set of variables and we try to construct or create factors using those set of variables. Now, what exactly are factors? Factors are latent, I can say latent variables. Now, can anybody who is sitting here, except for those who are from statistics, Tell me, what do we actually mean by latent? Hidden. Excellent. Abstract or hidden concepts that you very rightly mentioned. For example, जैसा उन्होंने बोला anger. There is no one way by which you can assess that. Frustration, anger, anxiety. There is no one way by which you can find it out. These are hidden concepts. So the purpose of factor analysis is to uncover that hidden concept. So you have a set of variables which you are using to assess that whether an individual has depression or not. There are, say, 15, 20, 25 set of variables. With the help of factor analysis, you can easily find out the underlying or the hidden structure of that data, which is not clearly evident from the set of variables that you have. वो कॉन्सेप्ट्स, वो फैक्टर्स जो अंडरलाइंग है, हिडन है, जो क्लियरली दिख नहीं रहे हैं विद द हेल्प ऑफ वेरिएबल्स, those can be identified using factor analysis, and those are called factors. So they are latent hidden variables. बनते किससे हैं? They are definitely made from those variables which you have in hand. But at the present state, they are not clearly visible or evident. So there are two basic ways by which it tries to group variable. Now, what do I mean when I say group variable? किसी बड़े dimension को if we are trying to reduce, how are you going to reduce that? कुछ set of variables के group बनाएंगे ना? How will you identify that set of variables which would come under one group? How are you going to identify that? Yes, one could be which have the same value. What could be the other way? When we talk in terms of statistics, then either we talk about, मतलब अगर हमें similarity find out करनी है, group बनाने हैं हमको, मतलब हमारे पास 25 variables है, we have 25 variables, and from those 25 variables, suppose we decided create 5 or 6 factors. अभी ये सब कैसे डिसाइड होता है? All of this we will be discussing in today's lecture. Probably none of you are asleep. Okay. So in today's lecture itself, we would be discussing that in detail. Number one, how do we identify that those set of 25 or 30 or whatever variables, how are we going to reduce them to say 5, 6 or what is that number? फर्स्ट वी हैव टू डिसाइड कितने में रिड्यूस करना है उस 25 को, 5 फैक्टर्स में रिड्यूस करना है, 6 फैक्टर्स में रिड्यूस करना है, 10 फैक्टर्स में रिड्यूस करना है. दैट इज नंबर वन क्वेश्चन. द सेकेंड क्वेश्चन इज, you have decided the factors, which particular variable is going to come under which factor. This is what I was discussing, that how are you going to create groups? So there are two ways by which we can do that. One and the most commonly used way is the correlation. Higher the correlation, better is the similarity. However, there is a lot of difference between the two terms. Correlation is very different and similarity is very, if we talk in terms of the statistics, there is a lot of difference between the two terms. But when we have to group the variables, so this is one way by which we can group them, that if they are highly correlated, we make one group or one set. The other is the covariances. So these are two broad concepts by which we can try to group variable, correlations or covariances. When we talk about different methods by which we can perform factor analysis, both the ways, by correlation as well as covariances, we can try to group the variables. But there are different methods. There are some methods which use correlation to group, some use covariances. We will be talking about some of them in this lecture today also, and some of them you might come across later on when you keep practicing. But there are both these concepts, correlation as well as covariances, all right, by which we can try to group the variables. So why use factor? I think this concept must be clear to all of you that when we have a large data set or many variables in a data set, then in order to reduce the dimension or reduce the size of the data, we need to perform some kind of dimension reduction technique and factor analysis, by which we can do that. What are the requirements? Now, univariate rather is not as important as multivariate normality is important when we talk about factor analysis, especially when we talk about principal component analysis. Now, PCA is one of the ways by which we can perform factor analysis. I will also be discussing about the difference between PCA and factor. The two terms should never be used synonymously. There is a lot of difference between fundamental difference between the techniques involved in PCA and factor. But broadly, for you all to just begin with, PCA or principal component analysis could be one such way by which you can perform dimension reduction. All right. So what are the basic requirements? Especially when we go in for a principal component analysis, the variables should have a multivariate normality. Now, can anybody just tell me what are the ways by which we can test multivariate normality? Okay, before I talk about multivariate normality, let me put it this way. What are the ways by which you can check normality? Any test? Kolmogorov, Smirnov, Shapiro-Wilks, very good. Any test by which you can test multivariate normality? I'm talking to people who are from non-statistics. I've told it in the class. Yes, it's called Mardia's test. That's one test that's available. There are other tests also that are available. Anybody else with any other name? So Mardia test is one test. It's available in R, I know for sure. It's not available in SPSS, that also I know for sure. It might be available in Stata, but I'm not very aware. But it's available in R, that I know for sure. It's one test, MARDIA. It is one test by which you can check for multivariate normality. This is one assumption, especially when we go in for factor analysis or PCA. The other is the absence of univariate and multivariate outliers in the data. Definitely, if we are talking about normality, and if you will have outliers, then there's no point of having a normal data, of course. So if we talk about normality, there need to be no outliers in the data. There has to be a linear relationship, specifically when we talk about principal component analysis. Variables need to be on a metric scale, that is on a numeric scale, and they all should have multivariate normality. Now, there's also another technique which is definitely not in our scope today, but that's also a multivariate technique, and that is called CAT-PCA, categorical principal component analysis. Very recently, I mean, today itself, we've communicated a paper of CAT-PCA, and that technique is a principal component analysis, but it is done for data which is on a categorical scale. So it has different set of assumptions. Initially, when I used to discuss it with some of my colleagues, that I'm doing PCA for data that's on a nominal or an ordinal scale, then everybody used to be very surprised. Just like multiple linear regression can also be performed if your variables are categorical. You know that? There's a concept of dummy variable. How many of you have heard that concept? So you can very easily perform multiple linear regression, even if variable is on a categorical scale. If a variable is nominal or ordinal, you can perform multiple linear regression using the concept dummy variable. Likewise is this concept of categorical principal component analysis or CAT-PCA, which can be performed on data that is on a categorical scale, either nominal or ordinal. That's a different technique altogether with a different set of assumptions, of course, but it can be performed. But right now, we are talking about conventional factor analysis methods, that is principal component analysis, that is performed on data that is on a metric scale. Now, the last assumption, actually, this is not a thumb rule, but I've also taken it from somewhere. But I would say that this is not an ideal scenario. It's written that a factor should have at least 3 variables, which means when you have a set of say 25 or 30, when we reduce it into factors, कुछ variable किसी factor में आएंगे, कुछ किसी में आएंगे, तो many literatures have reported that कि एक factor में at least you should have 3 variables. But again, it depends on the type of the study. It depends on the study objectives. Sometimes even 2 variable in one factor is sufficient. So this is not a standard statement, but it is written in the literature. Many statements that you find in the literature, it depends again on your study, like your study type, your field. Sometimes in management, we do shift the level of significance. It's not possible to have significant variables at 5% level. So we shift it to 10%, psychology, economics. So it purely depends on the type of a study objective, study design, everything. So you cannot clearly say it that there should be 3 variables. Ideally, there should be 3 variables. Okay. I hope you all are understanding what I'm saying. Everybody? So it is normally performed on metric again, but for non-metric, यहाँ पर भी dummy variable का concept होता है, but that's slightly advanced, so we would not be discussing it right now. However, there is another technique which is called CAT-PCA, which could be performed, which is a dimension reduction interdependence technique, which could be performed when your variables are on a categorical scale. Again, the last statement here is not to be taken too seriously, but yes, when we perform multivariate technique, the ideal results, the ideal outputs we get only when your observations are at least 15 to 20 times of your variables. But now we talk about high dimensional data. When we talk about high dimensional data, there are a lot of variables. There are only 200 variables and there are 50x for observation. So अब तो concepts ही change हो गए because the entire data sets are now different. But generally, अगर तो कई बार sample size को लेके issue होता है. But like now, if you go in for any study and if you apply that study for funding or anywhere, you have to properly give a formula for how you have estimated the sample size and all. तो वो चीज रही नहीं गई कि हम 400, 500, 300 ऐसे ही ले लें. Now the definitions, like now people are taking this too seriously, which is a good thing. But still, whenever you perform any multivariate technique, be it regression also, that's a very basic thing. Any multivariate, at least you should keep in your mind that your observations, the x's, should at least be 10 times and if possible 15 times of the number of variables that you are planning to have. Clear? Now these assumptions have already been discussed, so I am not going to, yes. So these two things are slightly new. No perfect multicollinearity and homoscedasticity. So since you all have studied linear regression and 3 hours of linear regression, so who's going to tell me what is multicollinearity? अभी तो पढ़ा होगा शायद, सुना है? अच्छा, how many of you have heard multicollinearity? मतलब कभी जिंदगी में नहीं, मतलब यहाँ पे how many of you have heard? अच्छा, सबने पढ़ा है. Very good. So that's a correlation amongst independent variables. No perfect multicollinearity means that there should be perfect correlation नहीं होना चाहिए, मतलब 1 नहीं होना चाहिए, but again having said that, variables need to be correlated with each other. वरना आप group कैसे बनाएंगे? अभी मैंने बोला that we will be dealing with the concept of correlation to make the groups. So variables need to be correlated with each other, but there should be no perfect multicollinearity. तो होना भी चाहिए और perfect भी नहीं होना चाहिए. That's So outlier is clear, linearity, interval, adequate sample size. What is homoscedasticity? ये भी अभी सुना होगा, डेफिनेटली सुना होगा. बताइए, हमारे स्टूडेंट्स नहीं, मतलब बाकी लोग बताएं. मैं इसीलिए बस कह रही हूँ कि हमारे स्टूडेंट्स नहीं, क्योंकि ये पढ़ते रहते हैं क्लास में, वैसे ये भी भूल जाते हैं लेकिन ये पढ़ते रहते हैं. सो एनीबडी, व्हाट इज? वेरी गुड. मतलब आप किस उससे हैं, मतलब योर स्ट्रीम? बताइए. खैर इकोनॉमिक्स में तो ये चीजें अच्छे से बताई भी जाती है. सो बट इट्स गुड दैट पीपल आर आंसरिंग इन दिस एफटीपी. गुड. सो homoscedasticity means that there should be constant variance. So यहाँ पे वो issue नहीं है. Since factor analysis is a linear function of measured variable, it does not require homoscedasticity between variables. Okay. Now, this test which is done using factor analysis. Now, what I'll do is I will be briefly explaining you about all these tests and the outputs. Don't take too much load. Just keep all these information to your head. Once when we all do it in SPSS, probably 45 minutes, I'll keep it for the hands-on and everything. So maybe in another 5-10 minutes, I'll wind up the theory so that we start with the hands-on. So don't take too much load by listening to all these terms. They are just for your basic FYI. Keep it in your mind. After we go into the hands-on, we'll be very clearly understanding what these terms actually mean. Now, when I said that for factor analysis, there should be no perfect correlation, but variables need to be correlated. For that, there is this test which is called Bartlett's test of sphericity. Now, since it's a test, it should have a null hypothesis and should also have an alternate hypothesis. So what's the null hypothesis for Bartlett's test? The null hypothesis is correlation matrix is an identity matrix. Can anybody tell me what's an identity matrix? Matrix पता है? Okay. What's an identity matrix? हाँ हाँ, मैट्रिक्स बन गई फिर. हाँ, diagonal elements are 1 and off diagonal elements are 0. Off diagonal elements मतलब समझते हैं क्या होता है? Other than diagonal elements. So identity matrix वो होती है जिसमें diagonal elements 1 हो गए and off diagonal elements are 0. मैंने क्या बोला इसमें? Correlation matrix is an identity matrix. इसका मतलब क्या हुआ? Correlation matrix सबसे पहले तो मैंने कैसे बनाई? Suppose if we have 25 variables and if you put it in a form of a matrix, how are you going to arrange it? 25 इधर हो गए, मतलब suppose rows में, और 25 columns में हो गए. ऐसे करके बन गया. आपस में variables में you are trying to see the correlation. Definitely the diagonal elements are going to be 1, क्योंकि उसी वेरिएबल का उसी वेरिएबल के साथ कोरिलेशन तो मैक्सिमम होगा ही. तो डायगोनल तो 1 होंगे. Let us talk about off diagonal elements. Off diagonal elements 0 कब होंगे? Suppose हमने डिप्रेशन का स्केल बनाया and we have questions like eating a lot or maybe eating less or sleeping like improper, like not properly sleeping, then fear of crowd, fear of social. इस तरीके से, मतलब अभी मुझे exactly वो सब ध्यान नहीं आ रहा. Suppose if we have those set of questions, आपस में उनका correlation if we try to find out, and if the value is 0, what does that, or maybe near to 0, what does that value means? There is no correlation between the variables. So now this is my question to all of you, and I want you, like anybody of you, to answer this question. अगर हमको फैक्टर एनालिसिस परफॉर्म करना है, इफ वी एम टू परफॉर्म फैक्टर एनालिसिस, हाउ शुड बी योर कोरिलेशन मैट्रिक्स? शुड इट बी एन आइडेंटिटी मैट्रिक्स और शुड इट नॉट बी एन आइडेंटिटी मैट्रिक्स? How many of you are saying it should be an identity matrix? How many of you are saying it should not be an identity matrix? Itna chota haath. Right. So it should not be an identity matrix. So ये जो हमारी null hypothesis है, that correlation matrix is an identity matrix for Bartlett's test of sphericity, it should be rejected. When is your hypothesis rejected? When your p-value is less than 0.05 if we take at 5% level of significance. Whenever you need to perform factor analysis, you have to perform Bartlett's test of sphericity and its null hypothesis should be rejected. Only if its null hypothesis is rejected, we conclude that data is suitable to perform factor analysis. Along performing Bartlett's test of sphericity, there is another way by which we try to find out that whether your data is again suitable for performing factor analysis or not. And that is called KMO measure of sampling adequacy. Abhi aapne multiple, I'm again and again trying to relate it with MLR because just now you've studied, so maybe you'll be very easily able to connect between the two. For multiple linear regression, what did we do? We try to find out R square. Capital R, what is capital R? Coefficient of determination. It tells you how strong is your model. The goodness of, after testing for the goodness of it, it tells you how well it is able to explain the relationship between dependent and independent. Similar, somewhat similar is KMO measure of sampling adequacy. This is the range. Again, it is not a standard like benchmark. This is again taken from some literature, which is generally used. But if the value is more than 0.7 or 0.75, we say that data is appropriate for factor analysis. So we've performed Bartlett's test of sphericity. We know there is some type of correlation, and we have also performed KMO measure of sampling adequacy. These two things are indicative of the fact that you can go ahead and do factor analysis. Some basic assumption checkings. PCA, as I said, is a common method to perform factor analysis. There are a lot of other methods, but broadly we do talk about this method. So I will only be demonstrating principal component analysis in SPSS. Regarding the outputs, KMO is one, Bartlett's test of sphericity is another. Then there is one more term which is also very important and plays a very important role, that is called communality. When we again talk about factor analysis, what is communality? ये तो इसकी definition हो गई, sum of squared component loadings. Now, right now you don't know what is component loading, so it might feel little alien to all of you. Read the second line that's written, represents the amount of variance in that variable accounted for by all the components. When I started this lecture in the beginning, what did I say? That variance is a very important concept. In fact, in statistics, variance is a very important concept. If there's no variability, there's no, like statistics won't be into picture if there is no variability. We only study statistics because there is a variation, right? Similar is the case with factor analysis. Communality tries to identify that how much variance is being explained by that particular variable, keeping it in a very simple terms. So when we get, so after checking for the assumptions, like after checking for KMO and Bartlett, the next important is that out of those 25 or say 30 variables that we have in a scale, which are those variables which are actually playing a significant role in explaining that particular phenomena which you want to study, be it depression or anxiety. Which are those variables which are actually playing a role? And that is identified by communality. higher the communality, more is the amount of variation that is being explained by that particular variable. तो जितना ज्यादा वेरिएशन एक्सप्लेन करेगा वो इसलिए बेटर है क्योंकि वो उतना प्रिसाइज है. Suppose amongst all of you, I am studying depression and there is one question which is necessarily different amongst all of you. What does that mean? The question is exactly addressing the phenomena. That is why it is different. Because ideally तो हमको यही find out करना है ना कि difference है, कहाँ है, कितना है और कैसे है. उसी के basis पे तो we will try to find out what's the level of depression or what is the level of anxiety. So communality is one such method, or rather one such way by which you can find out which particular variable is playing a significant role in explaining that phenomena. Okay. Then you have a scree plot. Now, what is the scree plot? I will be discussing when we talk about the output. So, मैं बहुत ज़्यादा stress नहीं देना चाह रही हूँ आप लोगों को because this is just day 2 of your MDA FTP. So, I want to keep it very light. So, I'm not going to discuss a scree plot right now. Let us make it and then we will discuss. All right. It's good to be chilled out. Next, what is component matrix? That also we'll be discussing when we talk about the outputs. So, concluding the theory part, some of the limitations of factor analysis, I think the only limitation of factor analysis is to name the factors. What are factors? Factors are the group of variables that you construct. And after we have group of variables, it is important that we name those variables also. That is one of the limitations of factor analysis, that sometimes it is a tedious task to name. Many of you who have done factor might also understand. So that is the only limitation, and if you have a large data, that's also sometimes difficult. Otherwise, it's a very good technique, and that is why we are all sitting here. So I request you all to please open your laptops so that, and open the data that has already been shared, that is personality. Giving you all 2-3 minutes to start with it. Hello. दीजिए घंटी बजा के मैं. Has everybody opened the data set? So this data set is basically, everybody settle down with the data. Okay. So this data is again data that's related to psychological assessment. So there are set of questions. अगर आप थोड़ा variable view में जाके देखें, before we start working on the data, at least you all should understand what the data is about. So if you see the labels, there are set of questions. How many questions? 44 questions related to different personality traits. whether a person is talkative, whether he is able to find faults in everybody, does a thorough job, repressed, original, reserved, helpful, careless, relaxed, curious, full of energy, starts, squirrels, reliable, tense. So these are set of questions related with a person's personality. Again, there are 44 questions. So there might be a need to reduce the dimension of the data. We should club these 44 variables in some factors which are related with each other. How many observations are there in this data? Quickly. 459. So definitely it is 10 times of the number of variables that we have. Now, how to perform principal component analysis? Go to analyze. Now, anybody can tell me which is the next step where I should go and click? Very good. So you all are now masters in doing factor analysis. I don't need to go ahead. You all can do it on your own. So we might end the class. Analyze, dimension reduction, and click on factor. Analyze, dimension reduction, and click on factor. As soon as you do it, there is a dialog box which opens up. Now, in that dialog box, what you will do, first step, put all these variables that are on the left to the right. Why are we putting all these variables to the right? Because we want to reduce the dimension for all these variables. अगर इसमें से कुछ set of variable पे factor analysis perform करना है, you can select those and put them to the right. ऐसा जरूरी नहीं है. जैसे generally when we collect the data, there are certain demographic variables also in that data, name, age, gender. So on those variables, you don't need to perform factor analysis. So it is basically done only for variables that are related to your study objective. In my data set, which is shared with you all, we just have information on those 44 set of variables, which are supposedly made for a scale that has to assess the personality. All right. But generally, when we do collect, we have information on other background characteristics also, which are not put in for dimension reduction. So you can use only those for which you want to perform that analysis. Put all those variables in the variable section. You can select all of them together. Select the first one, then scroll down, click on shift, click on the last. So by this, you will be able to select all of them together, put them to the right. After we've put all the variables to the right, next we go into the descriptives tab. For all those who are doing this for the first time, it's a request to please note down the steps. You all are doing it simultaneously, that's very good. But also note down the steps so that just in case you need to practice it later on, you have those steps written with you. When I studied SPSS way back in 2012, I do have the notes with me still, and I refer to those notes still. So it's a good practice that you keep maintaining the notes. There's nothing better than your own written notes, which you can refer to wherever you need to and whenever you need to. So click on descriptives. You can click on univariate descriptives, it's optional, but generally when we do multivariate or any type of analysis, the first table is generally the descriptives table. So if in case you want, you can get it here, you can get it elsewhere also. So it's a choice whether you want to click on univariate descriptives or not. Then click on KMO and Bartlett's test of sphericity. Everybody knows why we are doing it. Check for the assumptions. You can also click on coefficients. This coefficient part is written or is here just to like give you an idea that whether the variables are correlated with each other or not. हम उसको validate कर रहे हैं using Bartlett's test of sphericity, but this can also sort of add up to your information. So this is again optional. You want, you can click. You don't want, I mean, it's not needed for the analysis. So right now, since we already have too many tables, so we are not clicking on coefficients because we don't want to get confused. but that's an option for you. So click on KMO and Bartlett's test of sphericity. Continue. Then go to extraction. By default, we have this method of principal component. These are the different methods by which we can perform factor analysis. Right now, since we are only discussing about PCA, and that's an by default option that's already selected. So let it be selected principal components. Then click on scree plot. Again, why is this scree plot made? Let us keep the mystery still on and let us have the output, and then we'll discuss why are we getting the scree plot. Okay, definitely before 4:30 you'll get the answer. Based on eigenvalue more than one, let it be, don't change it. What is eigenvalue? Why it is more than one? That will all be answered after we get the outputs. So not changing anything here. Maximum iterations for convergence. Why do we need this? Why 25? Again will be answered when we get the output. Keep all these things in your mind. We'll get the answers once we run the data. Then click on continue. After that, click on rotation and click on vary max rotation. Okay, why we are doing it? We'll be discussing it when we get the outputs. Vary max rotation. Click on continue. Then click on options. Okay, so right now I'm not doing anything with the options. I'll do it later on. So you can just not open it. The scores also, I'm not doing anything right now, and I'll tell you what is the important. Maybe click on save as variables. Just click on save as variables in the scores. We will discuss it when we get the outputs. Click on save as variables. Okay. So I'm repeating it once again very quickly before we run the output. Put all the variables to the right. After that, in the descriptives, univariate descriptives and KMO and Bartlett's test of sphericity. In extraction, scree plot, and the rest of the options are by default. In case of rotation, vary max rotation. For scores, save as variables. And nothing for options as of now. All set to run? Okay. Now, after we've run factor analysis, we get the set of tables. Now, the first one is a descriptive statistics table. Because we've clicked on univariate descriptives, that is why we have this table. It tells you mean, standard deviation of all the variables. Nothing new, so we are not going to discuss this. Coming to the next, that is KMO and Bartlett's test. What is the p-value? First of all, let us see Bartlett's test. What is the p-value here? 0.000. What are we going to do? Who is going to interpret this for me? अभी पढ़ाया है just 2 मिनट पहले, 4 मिनट पहले. अच्छा, एक एक करके चलते हैं. एक्सेप्ट करेंगे कि रिजेक्ट? इतना देर कैसे लगा? हम एमडीए पढ़ रहे हैं, मल्टीवेरिएट, तो हमें बिल्कुल ये रट जाना चाहिए. Less than 0.05, you're going to reject it. What are you going to conclude? Factor analysis is appropriate. That's right. What is the null hypothesis for this test? Correlation matrix is an identity matrix. So in this case, it's rejected, which means correlation matrix is not an identity matrix, and that means it is yes. So which means you can go ahead and perform factor analysis. KMO measure of sampling adequacy में value कितनी आ रही है? 0.841. That is really good. So again, that's an indication that your data is perfect for factor analysis. आगे बढ़ते हैं. Communality. What did I say about communality? How much is that particular variable contributing to explaining the variation in that phenomena which you are studying? Ideally, the value should be more than 0.5. Any variable that has value less than 0.5 should be, or rather might be removed, and we can again perform factor analysis. One thing I think which should be very clear to all of you who are studying all these multivariate techniques, all these multivariate techniques, they are an iterative process. I mean, just now in the previous lecture, Dr. Akash must have told you about MLR, stepwise regression, forward, backward, right? All these techniques, multivariate specifically, they are an iterative process. You understand what's an iterative process? Just by entering the data, okay, getting the output won't suffice. It is not sufficient. We enter the data, we get an output, we try to analyze it. After we see the output, sometimes we feel that maybe certain variable is not playing an important role. Maybe certain variable is playing an important role, should be kept. Again, we remove it, redo the analysis. Then we get an improved version of the result. Sometimes we get a bad version, like a worse version of the result. So then we don't redo it. I mean, you're understanding. This is what I mean when I say any multivariate technique for that matter is an iterative process. We do it, then we get the result, then we try to analyze it, we see, and then we can again do it. That is the need why all these things cannot be solely understood by the software or by the YouTube videos. And that is the need why such kind of FDPs or maybe professors are needed. Because solely by watching that YouTube video, you do understand how to perform factor analysis. But you have to, at some point of time, use your own intellect to understand that, okay, out of those 44 variables, maybe if ऐसा कहीं rule नहीं है कि अगर आपके scale में 44 variables हैं, क्वेश्चनायर में 44 वेरिएबल्स हैं, तो आप उन सब पे फैक्टर एनालिसिस करें. देयर इज नो रूल लाइक दैट. इफ इट इज शोइंग अ लेस एक्सट्रैक्शन, if the communality is very low, you can straightforward remove that variable, indicating or stating that that particular question or variable is not playing a significant role in explaining the phenomena. You don't need to continue with that variable any longer. And maybe, I mean, you are revising your questionnaire anyways. So if you are revising your tool or questionnaire, you can remove that variable and go ahead with your analysis. So there's no fixed rule, no method which states that you have to use that variable. So it's an iterative. You have to continue doing. Similar is the case with MLR, factor, maybe cluster, conjoint, any type of multivariate techniques that you're going to study. So it's not the way that test की तरह नहीं है कि we've had the data, we've entered the data, and we get the p-value and the output. It's not like that. Okay. So here there are, I think, 2-3 variables that have value less than 0.5. Can anybody tell me very quickly? Star, squirrel. Okay. Now, अब यहाँ पर हमने क्या देखा? There are 2-3 variables. बस समझ गए. Okay, good, great job. Now, out of these 44 variables, there are 3-4 variables that have value less than 0.5. Now, one way is if we do as in we, मतलब अगर हम AI empowered होते, जैसा AI होता है आजकल, chat GPT and all, तो हम क्या करते हैं, जिसका 0.5 से कम होता, we would straight away remove that variable, be very happy and go ahead with factor analysis. This is not the case here. Why? Number one, we have a very good KMO. It's 0.841. Suppose if your KMO measure of sampling adequacy is very high, Bartlett's test of sphericity hypothesis is also being rejected, which means all the assumptions are necessarily being fulfilled. There is no point in removing 1 or 2 variables out of 44 that have less communality. There is no point in, you'll do that, it would be not wrong. But if you don't do that, then also it will be not wrong. So when you have a set of variables, just may say like you have 54 variables and out of which 2 or 3 variables have, or say 4 variables have less than 0.5 communality, but still you have a very high KMO measure, there is no point in removing that variable. You can very well go ahead and perform. आप इसको remove भी करेंगे ना, so there won't be much change in your KMO. बल्कि कई बार ऐसा होता है that KMO value might go down. Like you all have the data now, you have the software, you can go ahead and keep playing with the data. The more you will play, the more you will enjoy and the more you will understand. So keep practicing, keep playing. At least for these 5 days, you should go ahead and keep practicing. Maybe later you can just uninstall the software. That's your choice, right? But at least for these 5 days, you can continue doing it. So if the value is less than 0.5 and for 1 or 2, 3 variables, but overall KMO is high, you can very well keep those variables and go ahead with the analysis. So यहाँ पर, since we have a high KMO, so we are retaining these 3-4 variables as well and going ahead with the analysis. Is it clear? Now, very, very important table where, so how are we going to understand it? There are how many columns in this table? Column मतलब समझते हैं? 3, 3, 6, 3, 9 और 1, 10. So there are 10 columns in this table. So we first start with column number 1, that is how many components. By default, any software, or maybe let's not focus on the software, by any way by which you perform PCA, it by default creates as many components as there are number of variables. So you have how many components? 44 components by default. पहला step तो ये होता है. There's no doubt in that. Now, what is the next step? We try to find out how much variation the particular component is able to explain. Definitely, we are talking about variation. And why we are talking about variation? I think it's clear to everybody. Higher the variation, the better is that particular variable or a component, because it is able to explain the phenomena in a better way. So higher the variation, better it is, right? Also, the way it is made, by default, first component will explain the maximum variation and then it will keep going down. So ये भी हमेशा होगा कि arrange ही इस तरीके से किया जाता है that your first component is going to explain maximum variation and then it goes on reducing. Okay, then next. How much, so this is how much is the variation being explained. This is the, this is the eigenvalue. I'm sorry. Second column is the eigenvalue. Now, do you remember when we were running this, there was an option that said eigenvalue more than 1. What does this mean? Eigenvalue more than 1. And what is eigenvalue? How much variation that particular component is being able to explain divided by the total variation that is present. Definitely, if it is more than 1, it means that particular component is able to explain a good amount of variation. So those many components we try to retain, those have eigenvalue more than 1. This is the thumb rule. Take. So out of all these 44 components, how many components have eigenvalue more than 1? 10 components. 10 आपकी eigenvalue आ रही है 1.044. So we are trying to retain 10 components. यानी पहला decision तो हमने बनाया. क्या हुआ? These set of 44 variables are going to be reduced into 10 components or 10 underlying factors or 10 latent variables. कुछ भी कह लो. unobserved variables, latent variables, factors, components, whatever you call. These 44 variables you are going to reduce into 10 components or 10 factors. That is one decision that we've made right now. Now, how much is the percentage variation being explained? अब ये next वाले third column की बात करते हैं. जैसा मैंने बताया, by default, first component is going to explain maximum variation, and जैसे जैसे हम नीचे जाते जाएंगे, the variation is going to reduce. So first component is explaining 16.5% variation, then you have 9% and so on. Till 10th component, we are able to explain 2.373% variation of the total variation. Okay. This is the cumulative percentage. So overall, these 10 factors or components are able to explain approximately 60% of the variation, which is a good amount of variation that your components are able to explain. If it is more than 60, 65, we do say that it is a respectable number. So it's a good amount of variation that these components are able to explain. In सब ने ऐसे ही copy करके next 3 columns में डाल दिया. So there is no difference between the first 3. Like, let us remove the components wala column. First 3, they have just been copy pasted to the next 3. क्यों अलग किया? Because these are the 10 components that have eigenvalue more than 1. Is this clear to all of you? Sure. The last 3 columns are the rotated sum of squares. Now, first of all, if you remember, rotation पे गए थे, and rotation पे जाके we clicked on vary max rotation. What exactly is vary max rotation and why do we need to do it? Suppose, like, we know that 58% variation, 58.289% variation is the variation that is being explained by these 10 components. Okay. What is the fundamental concept of factor analysis? जो हमने पहले, first line that I discussed here was variance. What is the objective? To maximize the variation. जितना मैक्सिमम वेरिएशन वो पर्टिकुलर फैक्टर या वेरिएबल एक्सप्लेन करेगा उतना बेहतर होगा, एंड जितना लेस वेरिएशन होगा उतना देयर इज नो पॉइंट ऑफ स्टडीइंग द कॉन्सेप्ट, राइट? Varimax is one such way by which, keeping the total variation constant, you try to maximize the variation explained by each component. Right? I'm repeating it once again. Keeping the total variation constant. So 58.289 पहले भी उतना ही था, and last column के last value में भी 58.289 ही है. So we are keeping the total variation constant, but we are trying to maximize the variation explained by each and every component. अब हम ये कैसे करेंगे? अगर आपने टोटल फिक्स कर दिया और एक एक का वेरिएशन अगर आपको मैक्सिमम करना है, किसी का बढ़ाने के लिए किसी का तो कम करेंगे. That's the logic, because you are keeping total variation constant. This is exactly what iteration and convergence means. Now, you remember there was an option, maximum iterations required for convergence, 25. What does this mean? We repeat this process of maximizing the variation by each component. तब repeat करते हैं जब तक एक constant value attain नहीं हो जाती. That is called convergence. Are you understanding what I'm saying? I'm trying to keep it very less statistical, but at least you need to understand the concepts. Iteration मतलब समझते हैं repetition. Convergence, you are getting a value that's fixed. तो अब यहाँ पे आप देखो क्या हो रहा है. पहला कंपोनेंट 16 की जगह अब कितना परसेंट वेरिएशन एक्सप्लेन कर रहा है? 9.972. दूसरा वाला पहले 9.57 कर रहा था, अभी कितना कर रहा है? 8.4. The third 6.9 and now it is explaining 8.05. तो किसी का बढ़ रहा है, किसी का घट रहा है. But so 25 is one cutoff जहां पर mostly we do get a value that is constant. Sometimes we don't reach convergence at 25. So software shows you a warning that convergence is not attained and you might increase the number of iterations. तो वो 35 भी हो सकते हैं, 50 भी. Software does show you a warning that convergence is not attained. तो आप iterations को increase भी कर सकते हैं. Right? ये concept समझ में आया सब. अब यहाँ पर सबके वेरिएंस को मैक्सिमाइज किया जा रहा है. Each component is being able to explain maximum variation, keeping the total variation explained constant. So total variation here is 58.289%, but हर एक के individual variations थोड़े से change हो गए, and this is why we do rotation. Why do we do varimax rotation? Especially if we have metric data, multivariate normally distributed data, all the different methods of rotation, varimax is the best used for principal component analysis. Principal axis में कुछ और use करते हैं, ठीक है. Different methods में different types of rotations use किए जाते हैं. Different data sets के लिए different types of rotation use किए जाते हैं. But when you have a multivariate normally distributed data and you are ready to do PCA, the best way to maximize variation is to do it using varimax rotation. So are all these tables clear to all of you? Sure. So we have 10 components, that is 10 factors, and each factor is explaining certain amount of variation, and we've tried to maximize the variation, and overall variation is 58.289%. What is the next question that needs to be answered before we go into the next table? 10 component. तुमने scree plot को छोड़ो, वो तो दिख रहा है इसमें. वो मैं आऊंगी scree plot पे, don't worry. I won't let you go with a broken heart. I will tell you, don't worry. But what's the next question that we need to answer? Let us think of the objectives of factor analysis, which I was discussing in the beginning. पहला point तो ये हो गया, data suitable है या नहीं. We know it is suitable. Second हो गया, how many dimensions? 10. What's the next question? Very good. कौन से items या variables किस component में जाएंगे? 10 component तो समझ में आ गए, but the next and the last question that needs to be addressed is which variable needs to go into which component? चलो अब बताइए दे इसको. हाँ. So this is a graphical way by which we try to find out how many components or how many factors are to be created. तो जो चीज हमने ऊपर आइगन वैल्यू से करा है वो ये ग्राफिकली बताता है. अब ये कैसे बताता है? It has to take a shape of an elbow. So wherever there is this elbow, कैसा होता है? ऐसा होता है ना, मतलब everybody knows what's the shape of an elbow. So where there is this joint, मतलब ये जो कट होता है elbow का, that is the point where we say that अच्छा इतने number of factors होने चाहिए या इतने number of components होने चाहिए. अब बताइए कितने, कहाँ पे elbow दिख रहा है? यहाँ पे elbow का कट कहाँ पे दिख रहा है? किसी को 5 पे दिख रहा होगा शायद, किसी को 7 पे दिख रहा होगा. Actually this is a very weird way to find out the number of factors. I don't like this graph at all. Why I'm saying this? I think any graph for that matter. I mean, you all are now doing multivariate analysis, so you all know graphs can only give you an idea. They are not a decisive method, है ना? तभी तो हम normality, if we need to check, why can't we only try to find out normality using a histogram? We make a histogram, but we also perform Kolmogorov-Smirnov or Shapiro-Wilks or Anderson test or whatever. So we do perform these tests along with histogram or a box plot or a stem and leaf. So graphs are a way they can sort of augment your findings, support your findings, but they are not decisive. तो free plot का prime objective ये है to tell you how many factors are required, but this is not a decisive way. I might feel कि elbow 5 पे बन के आ रही है, कोई बोलेगा नहीं नहीं वो proper elbow तो 9 के करीब बन के आ रही है. So this is a subjective way. Graphs anyways are subjective because they depend on interpretation. So whenever you do factor analysis and when you want to get your paper published, आप आइगन वैल्यू के बेसिस पे डिसाइड करिए, इसको लगा दीजिए क्योंकि ये सब देख के थोड़ा लगता है ना that we are doing some advanced analysis. So this might just make your paper beautiful, that's all. So coming तो इसका नाम बहुत अच्छा था, but इसका काम वाम कुछ नहीं है. So coming after the scree plot, the last question that we need to address, and that is which variable is going into which component. There are two ways by which you can do it, either seeing the component matrix or seeing the rotated component matrix. We are going to see the rotated component matrix. Why? Because we have performed rotation. यही अगर आपने rotation नहीं किया होता, you would have decided it on the basis of component matrix. So we are going to skip the component matrix and we are going to move into rotated component. यहाँ पर इसने automatically 10 component के लिए ही बनाया है. If you see the rows, there are 10 components. Why 10 components? Because these 10 components have eigenvalue more than 1. तो ये decided है कि 10 ही factors में हमको reduce करना है and it is able to explain 58.829% variation. Now, answering the question, which variable goes into which component? Starting with talkative. First variable. There are 10 components. How to decide that it will go into which component? For whichever component the value is maximum, talkative will go into that component. By maximum, mean the magnitude irrespective of the sign. तो कहां पर maximum हो रहा है? So talkative goes into component number 2. I am repeating it once again for people who have not been able to, क्योंकि यही इसका main part है. If you see the values, पहला वाला कितना आ रहा है? 0.142. The second is minus 0.658. Third is 0.019. Fourth is 0.388. Fifth is 0.185 and so on. सबसे बड़ी वैल्यू कहां पे आ रही है? Second, minus, ignore the sign and see the magnitude. Sign का मतलब होता है वो negatively impact कर रहा है या positively. So that's not important. You just need to see the value, the magnitude. So it is 0.658, maximum amongst all 10. So talkative goes into second. Finds fault पे आइए. Sixth. Okay. Very good. Does a thorough job. First. Depressed. Third. Original. Seventh. अब ऐसे now what is happening here? कोई first में जा रहा है, कोई second में जा रहा है, कोई third. So what should be done? Either you take a sheet of paper and then you keep on writing सारे components में कौन कौन जा रहा है. To even make it more easier, let us do it. Go to the data part. Again, go to analyze, dimension reduction, factor. In the option section, the rest of the things will remain as it is. In the option section, click on sort by size. पहले हमेशा खुद से पानी में डाला जाता है कि स्विमिंग करने की कोशिश की जाए, उसके बाद गाइड आकर के हमेशा बताता है ना. God also puts you into difficult situations sometimes to figure out how you can try to get out of that. Go to options and click on sort by size. The rest of the options will remain as it is. click on continue and click on OK. दोबारा से रन कर गया. The rest of the tables are very easily understood. तो हम उसके बारे में बिल्कुल भी नहीं जा रहे, कुछ फर्क नहीं पड़ेगा किसी में, सब कुछ ऐसा ही है. तो आप लास्ट वाले पर आ जाओ बस, रोटेटेड मतलब सेकंड लास्ट वाले पे. तो आप देखो कुछ फर्क लग रहा है आपको क्या? नंबर नहीं बदले. तो अब आपको क्या समझ में आ रहा है इसको देख करके? डिसऑर्गेनाइज्ड से लेके और डिट्रैक्टेबल तक, all the variables are coming into component 1. Now my next question to all of you is, are these variables similar? Of course they are similar. If a person is disorganized, a person would definitely be lazy. If a person is disorganized, a person would be careless. Efficient मतलब scale बदल जा रहा है. But disorganized and efficient are almost like exact opposites of each other. But अगर कोई disorganized है तो उसकी efficiency compromise होगी ना. अब आ जाइए नेक्स्ट वाले सेक्शन पे. चलो अगर पहले वाले पे डाउट हो रहा है कि मैम ऐसी बना रही हैं, कम टू द सेकंड कंपोनेंट. व्हाट वेरिएबल्स आर देयर इन द सेकंड कंपोनेंट? क्वाइट, रिजर्व्ड, shy, talkative, outgoing, assertive, all of them are similar. So ये चैट जीपीटी से पहले वाला चैट जीपीटी है फैक्टर एनालिसिस. So this is what is the main objective of factor analysis, that after we have decided 10 components, similar variables को एक एक component में क्लब करते जाना. तो कुछ नेक्स्ट स्टेप ये होता है दैट यू ट्राई टू नेम दीज कंपोनेंट्स, कि कौन सा वेरिएबल किस कंपोनेंट में आया. ठीक है. आफ्टर वी हैव नेम्ड दीज कंपोनेंट्स, देन इट इज आवर डिसीजन कि क्या हम उसके सारे वेरिएबल्स को लें या फिर जिसकी कम्युनैलिटी लो है उनको हम उसमें से हटा सकते हैं. लाइक सपोज इफ वी ट्राइंग टू अंडरस्टैंड दिस कॉन्सेप्ट ऑफ लाइक कितनी एफिशिएंसी है, तो इतने सारे एफिशिएंसी वाले वेरिएबल्स लेने की जगह जिसकी कम्युनैलिटी लो है, you can easily remove those variables and keep only those which have high communality, right? One more step. यहाँ पे तो like the class is over and wait, the time is also 4:30, but just taking 1-2 minutes more. This is just that like we've done factor, we've reduced the dimensions, but MLR factor ये भी एक iterative technique है. MLR करते हैं, हाई मल्टीकोलिनियरिटी आती है. पता है मल्टीकोलिनियरिटी क्या होती है? एक्सेस आपस में हाईली कोरिलेटेड है. एमएलआर किया, हाई मल्टीकोलिनियरिटी आई, फैक्टर एनालिसिस परफॉर्म की, डायमेंशन रिड्यूस किया. उसके बाद अगर आपको याद होगा, हमने सेव पे जाके एज फैक्टर स्कोर क्लिक किया था. ठीक है, उसके बारे में रह गया. हाँ, गो टू द डेटा. If you go to the data, scroll to the last. Now यहाँ पर 2 बार क्रिएट हुआ है अभी. Why 2 times? Because we have run the analysis twice. वो सॉर्ट बाय साइज करके हमने दोबारा रन किया था ना. But what will happen? It will create 10 variables. मतलब ये जो दिख रहा है fact 10_1, ऐसे करके इसने 10 वेरिएबल क्रिएट किए हैं. ये वेरिएबल्स कैसे क्रिएट किए हैं? जो ये फैक्टर के स्कोर हैं, यानी एक फैक्टर में 10 वेरिएबल आए, सॉरी 10 फैक्टर आए और हर फैक्टर में कुछ कुछ वेरिएबल्स आए. किसी में 7 होंगे, किसी में आई डोंट रिमेम्बर द एग्जैक्ट नंबर, बट जैसे वो डिसऑर्गेनाइज से लेकर के और लेजी वो सारे, तो पहले फैक्टर में कुछ आए, दूसरे में कुछ आए, तीसरे में. उन सारे वेरिएबल्स का जो स्कोर था, जिसके थ्रू उसने ये सारी स्टेटिस्टिक्स करी, उसको कंबाइन करके दे क्रिएट 10 न्यू फैक्टर्स. सो कई बार ऐसा होता है, इंस्टेड ऑफ यूजिंग those 44 variables, वी हैव क्रिएटेड 10 न्यू फैक्टर्स, ये वो 10 नए वेरिएबल हैं, एंड डायरेक्टली इन 10 वेरिएबल को यूज करके हम दोबारा से MLR रन कर सकते हैं. So when I'm saying it's an iterative process, you go for MLR, this high multicollinearity, go for factor, create 10 new factors, जिनका कि ये अब ये नए वेरिएबल बन के आ गए ना, 10-20 बन के क्यों आ रहे हैं? Because we've done it twice, otherwise you've 10 set of 10 variables. Rerun the analysis and you get the output with reduced multicollinearity, rather no multicollinearity. So that's all from my side. Thank you so much. If you have any questions, you can ask. Achha, okay. So there's this online question that we have to sort the that how can we sort the rotated component matrix. So maybe I'll do it once from the. So, okay. How do we decide that which variable goes into which component? जिसकी value maximum होती है वो. So here what it has done already, पहले में जितने maximum थे उन सारे variables को एक साथ कर दिया. देन दूसरे सेकंड कंपोनेंट में जितने मैक्सिमम थे उन वेरिएबल्स को एक साथ कर दिया. देन थर्ड कंपोनेंट में जितने मैक्सिमम थे उन वेरिएबल्स को एक साथ कर दिया. फोर्थ, फिफ्थ, सिक्स्थ एंड सो ऑन. So automatically it has arranged the variables in such a way that the one having the maximum variation goes into one component, then second, third and so on. I'm coming to, let us first answer the online questions.
Right, but he's asking that there is something called damage reduction of the data analysis. It's that seems in that case also.
Yes.
Similarly, questions like factor
Factor analysis, सबसे पहले तो it is used for dimension reduction. It is used to address multicollinearity. Sometimes we also need to check for the validity of the scale. In that case also we go in for exploratory factor analysis. Validity and validity of the scale. External validity establish करने के लिए also we go in for factor analysis. कोई भी question आया नया develop कर रहे हैं तो उसमें. Any other questions?
we have primary data.
Maybe you can see the communality, and in that case variables which have really less communality, that's maybe 0.3, 0.2, 0.4, you can remove those variables, rerun the analysis and then see that maybe after a set of variables maybe you have a significant KMO and Bartlett's test of aspiracy. Yes. Yes. आप लोग इतना बात करेंगे तो you will not be able to understand her question. She's asking good questions. What dotted part you are talking about? So if you have information that is missing on any of the variables, then generally multivariate techniques do not perform for that. Automatically पूरी मतलब थोड़ा sample size reduce हो जाएगा. Effective sample size would be reduced. It will only work on the variables which are non-missing. Income age हमेशा हटा के demographic variables remove करके we perform. हाँ, but that's a different concept. Regression में तो you have an dependent and an independent variable. You have set of variables in factor analysis and you are trying to reduce the dimension. तो आपस में वो interrelated, highly correlated होने चाहिए. इनकम एज इसके बेसिस पे थोड़ी हमको कोई कॉन्सेप्ट पढ़ना होगा. कुछ सेट ऑफ वेरिएबल्स होंगे ना, तो हम इनको हटा के आई मीन वी विल नॉट यूज देम फॉर फैक्टर एनालिसिस. Yes, definitely you can do that.
One query online. Someone asked, but great transformation practices.
Okay, I think that was the last matter. Yeah. So this basically tells you that you have 10 components. You've made 10 components. It tells you how are those components related with each other. That's all. Yes.
Can you please explain the concept eigenvalue?
So eigenvalue is basically how much variation is being explained by that particular variable and the total variation that is explained. So if it is more than one, it is good, and that's why we retain those components which have eigenvalue more than one. So thank you so much. That's all from my side now.